Great, we're live. Good afternoon. Welcome to SparkFun's Echo Chamber. How's that? That's better. Okay, great. I'm Jeff Branson. Today we're going to cover doing data visualization with the Raspberry Pi. So I'm going to start out with a Python example. You can see I've got my Raspberry Pi, and we'll take some shots of the wiring for this. I'm going to start out with an I²C sensor. We're going to take a temperature reading and do a data visualization and a really simple implementation of Tinctor, which allows us to do some graphics, but we're going to do a live graphing visualization with Tinctor, which is a really teachable example for classroom use. So just kind of getting started, building graphing stuff. There's some incredibly powerful tools for Python for doing data visualization. It's become one of the preferred languages for data viz. Matplotlib is super popular. We've got some tutorials on that, but I want to start out kind of in a scaffolding that takes Raspberry Pi from the ground up and builds a graphing example from there. And then we're going to tackle the age-old question with Raspberry Pi of how do we do analog conversion? Because the Raspberry Pi doesn't have an analog to digital converter on it natively. So I've built an Arduino example. We'll look at installing Arduino on the Raspberry Pi. We'll look at installing the processing language, which is actually the mother language of Arduino on the Raspberry Pi. And then we'll get a data visualization working in processing using an analog read. So hopefully this will be a nice, full, and informative afternoon for y'all. And the first thing I'm going to do is actually go to one of our tutorials to get started. So on learn.sparkfun.com, we have a Python programming tutorial. So if you put into your browser SparkFun Python programming tutorial or Python getting started with Raspberry Pi, SparkFun, you should end up on the page that's on your screen right now. So what I'm going to do is this actually goes through the basic setups for the Pi, and it goes through a hello world thing, and there's a lot of really useful Python information in here. But what I'm concerned with is actually experiment number 4, which is an I2C temperature sensor. So if I click on this, here's my page. This is great content written by Sean. If you're a SparkFun devotee, you know Sean. Sean's done a lot of really great material for us through the years, and this is no exception. So the tutorial lays out a basic wiring diagram, and I'm actually going to pull up the fritzing right here. And this is how I have my TMP 102 sensor wired here on the desk in front of me. The TMP is probably the simplest I2C sensor that I've ever seen. Really easy to get started with, great to do basic examples. So if you're in a classroom setting and the idea is how do I get kids started with I2C sensors, this is a great example. The second graphic in this tutorial is actually the direct hookup. So if you don't have a Pi wedge, you can just use the wiring diagrams. And I2C is 4 wires. It's a power wire, a ground wire, a data line, and a clock line. And those 4 lines allow us to control these smart sensors, these I2C sensors. Great. So following along, what I'm going to do is actually log on to my Pi. So I've got a Pi here on the desktop, and for ease of entry, what I'm going to do is actually VNC into that Pi. And I've already set up a virtual network connection, and I'll log on to the Raspberry Pi. And you should see the desktop for my Raspberry Pi. So to make things easier, what I'm going to do is actually pull up the tutorial in the Chromium browser on the Pi. And one of the things that we know about the Pi is that it's not super fast. So adjusting some of the timing and stuff for these examples can really help out the performance of the examples. So here I am on the SparkFun page. I'm going to go down to experiment 4, and there we are. We're logged on. So the first thing I'm going to do, and I jumped off my VNC. The first thing I'm going to do is scroll down, and there's a sudo apt-get install python 3 SM bus, and the SM bus actually controls the I2C communication protocol on here. So if I run that in my terminal window, and actually if we go back, there it is right there, because I ran this earlier, and it'll go through, it'll read. It tells me it's already the newest version of this. Super cool. So what I'm going to do is I'm actually going to copy this code, and I get that, and I'm going to go over to my Raspberry Pi menu. I'm going to grab Python 3. When Python 3 launches, it's going to give me the shell. So from the shell menu, I'm going to open a new file, and I'm going to paste this code in there. So I'm going to save this code as tmp102.py. That .python extension tells the computer that we're going to compile and execute this code with a Python engine. So when I hit save, it gives me a tmp102.py file. If I go to my run options and click run module, and everything's good, you can see in my shell window that once a second I'm getting a Celsius temperature reading. So I know the I2C sensor is working. I'm going to Control C to stop this. So my keyboard interrupt stops that Python program from running. Let's take a little look at this program and just kind of chat through a little bit of what's going on here. So at the top of the program, we've imported time for the time module and SM bus for the I2C functions. So an I2C channel is set to 1, and an I2C address is set to the hex address of the register of the device, and that's hexadecimal at 48. OX is our notation for hexadecimal numeral systems. So I have 2 register addresses, a regular temperature and a regular configuration, and those are 00 and 01 respectively. So when this sensor gets pinged, basically what it does is it returns a frame of data in binary, and we use 2's complement to convert that binary into a decimal number, like kind of a human readable number. And then the read temperature function basically busts out how we get that 2's complement into temperature Celsius. And it gives us a little offset for calculating that, and returns temp C. So if I move down, we've got some simple print samples, a little bit of magic configuring the registers on the device, and then finally a print statement which gives me the temperature and a little bit of text C. And then finally we close that out with a time.sleep of 1 second. So that's the rough of what's going on as we're watching this in the shell. what I want to do is I want to get this data into something that's a little more humane, a little more readable than just the shell. And so what I've chosen for this example is to use Tinctor. Uh, and Tinctor is uh, pretty pretty common stuff, and or actually I'm using Turtle. I'm sorry, I'm not using Tinctor, I'm using Turtle. But really common for first-time graphic stuff with kids. So the first thing I'm going to do with this code is I'm going to add import Turtle. And that gives me the Turtle module. Then I'm going to declare a screen size on here. So I'm going to say I want a window, WN, and I'm going to set that window equivalent to turtle.screen. And turtle.screen is a function, so I'll close that out with parentheses. The next thing I'm going to do is declare my window size. So I've declared that window function as an object that I call WN, short for window. So now I can start using that object notation, and I'm going to say WN dot screen size. And I'm going to give it an X and a Y coordinate. So I'm going to say 1,000 pixels wide by 800 pixels deep. Close that out. That looks pretty good. Let me save this out as, oh, let's say TMP 102 plus graph. Yeah. Now I'm going to give this a test just to see how this goes. I'll run the module out to make sure I haven't made any mistakes. And I didn't capitalize screen. So I'm going to go back and fix that. I always think it's a nice idea to model failure. At least that's what I tell people. Control S and I'll function 5, run this. And there's my screen. And you can see next to my screen, I've got my sensor reading out. This all looks good. We can move on from here. So I'll Control C out of the Python run, close that window out, and start working a little farther down on this. It's a really common practice for me to write a little code, test the functionality, write a little more code, test the functionality. So the next thing I want to do is I want to create something to draw with. So I'm going to create another object that I'm going to call pen. And I'm going to say pen equals turtle.turtle. Good. The next thing I'm going to do is, because pen is part of the turtle functionality, I'm going to tell pen in its drawing function to pull the pen up, to not draw. So if I didn't do that the first time I launched this, if it moved from the center of the screen, which is actually the middle of the screen, to someplace else, it would draw a line immediately. So I'm going to pull the pen up in order to keep it from drawing. And I'm going to say pen dot pen up. Again, that's a function, so I'll close that out. Then I'm going to give this a pen size. So I'm going to say pen dot pen size. And I think I want my pen size to be 4 pixels wide. So I'm going to pass this the parameter 4. So now what I want to do is I want to move my pen to the lower left-hand corner of my window to start graphing from. So I'm going to say pen.setPosition. And I'm going to give this coordinates, and I'm going to be negative 430, comma, negative 350. And actually, I need to coordinate those. I need to make those into variables. So I'm going to build a couple of variables up here. And I'm going to say xcoord equals negative 430. Enter. Y-chord equals negative 350. The reason I set these as variables is so as we drop into the loop portion of the program, I can start to change those variables. Without variables, I'm not going to be able to change them. So I'm going to go back to set position, and I'm going to pass it xcoord, comma, y-chord, an ordered pair, and close that out. So once I move there, I want to start drawing. So the next thing I'm going to add to this is pen down. And that's a function also. So close that out. I'm going to save this, and I'm going to see if I broke it or not. And there we go. So you can see that I started up my window, my cursor moved down to the lower left-hand corner, and I'm getting readings from my temperature sensor. This is disarmingly successful so far. Usually I break things a lot faster than this. Control C. Megan, how are we doing? Got any questions?
Good.
We're doing good. Okay, great. I'm going to keep going here. So once cool. So we may have lost people for a little while, but don't be alarmed. Did we lose just the live video or the screen as well?
Oh no, we just left.
Okay, great. So the next thing I'm going to do is all of this code for the TMP 102 is functioning really, really well. I don't need to mess with that. Oops. I'm going to go down to the bottom of the code, and in the bottom of the code is a while true statement. And that while true statement sets temperature equal to the read temperature function. It prints it out, and then it waits for 1 second. So what I'm going to do is I'm going to set my x and y coordinates based on what the temperature is as it goes through that while true statement. And the way that I'll do that is that underneath time.sleep, I'm going to start a new line, and I'm going to say y-chord equals negative 350. It's my home position, plus temperature. So it'll move up. That looks good. The next thing I need to do is do something with my x coordinate. and we want to increment my x-coordinate over as we go. So we're just manipulating our variables right now. I'm going to say x-coord equals x-coord plus 2. That looks good. And then finally, I need to move my pen according to what these variables are. So I'm going to say pen dot set position, set pos, and I'm going to say set it to my x-coord, comma, and my y-coord. There we go. Relatively simple. Let's test it. Control S to save, function 5 to run it. And set pos was not defined in this, so I need to go back and check my code. Oh, I'm not dotting. So I put in, rather than pen.setPos, it was pen. Okay. Control S, function 5. And my cursor moved up immediately. That's my first 24 from where it initializes. And you can see that my cursor is moving across the screen. And if I reach over and I squeeze and heat my sensor, you can watch my cursor start to rise. So I'm getting a real-time graph here. And you can see as it runs through the shell, it's going up, and my body temperature should level off about 32 degrees Celsius. If I let it go again, we should see that go down. And it's dropping, and you can actually see it start to drop. Leveling out about 30 degrees Celsius, still going down a little bit. Now, the lag in this is because of my time.sleep. And I'm going to close this out and see what it looks like when I block this a little more slowly. So if I go, instead of 1 to, let's say, 0.5, which would be half of my current delay, this should work twice as fast. And there we go. So a few more data points per time, a little more real time there. Very good. Okay. So I'm going to add the GitHub link to all this code to the comments below the YouTube on here, so you can get a hold of this code, a finished version of this code yourselves. Feel free to fire any comments you have at us. Megan, how we doing? Anything from the web?
We are good.
Okay, great. So that's basic Python example. And most I2C sensors follow this basic protocol of read-write. Changing the addresses would be approached by reading the addresses on the data sheet and substituting them into code like this, or even this code, and seeing where you come out with that. So if you have specific questions, we can do our best. A few internet searches usually yield some pretty rich results. So I would, that's my first step in anything. So What I want to do is I want to move on to processing. So I'm going to close out Python. Thank you, Python. So I want to talk a little bit about the implementation of processing for the Raspberry Pi, because it's a really interesting build. And if I just put in processing Raspberry Pi and I hit enter, the first hit I get is from the Raspberry Pi Foundation, raspberrypi.org, and it says now available for download, processing Raspberry Pi. The sweet part about this, this was written by Matt Richardson. If you're not familiar with Matt, he does amazing work. His book on Python and Raspberry Pi is highly recommended. But the coolest thing in this whole article, and blah, 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 is this line right here. Because curl.https allows me to just take this line of code, put it into the terminal, and you can see if I scroll back through my commands, there it is. I put it in. I installed processing on the Pi, and when I go to my menu, it actually loads into the processing or into the programming section right here. And you can see I've also got Arduino installed on this. So what I want to do is I actually want to build an analog sensor based on an Arduino and then build a data visualization based on processing. So let's go through what that looks like. So I've done the install for Arduino, one line, sudo apt-get install Arduino, and it's on your machine. So, Cassie, are we ready to cut? So I've got an Arduino, and this Arduino is set up with an analog potentiometer right here, and it's reading through port 0, analog port 0 on the Arduino. I'm going to plug that into the USB connection on the Pi. And when I do that, and I open Arduino, it's going to take me a little while because Raspberry Pi is really slow. So here's my Arduino sketch. If you're watching this, my guess is you're pretty familiar with Arduino. I'm going to go to Tools. I'm going to make sure that I'm on an Arduino Uno. Indeed, I am, and I have a serial port, dev TTY USB 0, which is usually the first serial port that enumerates on any Linux system. So the next thing I'm going to do is go to File, Examples, and I'm going to go down to Communication. And in Communication is a sketch called Graph. If you've ever used processing anywhere else, you may be familiar with this. I'm going to open Graph. And Graph gives me two chunks of code. The top set of code, which has got the colored Arduino call out for commands that it recognizes, is the Arduino code. And then below that, you can see commented out right in here. It says processing code for this example. Well, I'm going to make a couple of changes. The first thing I'm going to do is I'm going to knock down the serial speed on this so that the Arduino and the Raspberry Pi are speaking more slowly to each other. It's kind of like two people who aren't speaking their first language. The Raspberry Pi is slow, and the Arduino needs to slow down in order to deal with the Raspberry Pi's kind of native recalcitrance or whatever it would be. So I'm going to change my serial.begin to 1200 bits per second, 1200 baud. And then my delay I'm going to bump up. I'm going to bump this up to 20 milliseconds. So I'm going to load that code. I make those two changes. And it took me a little fussing with this to figure out how to get this to read. If you open this right up and run it, you get a lot of drop numbers where basically the Raspberry Pi can't read the serial connection fast enough. So the next thing I want to do is I want to check my serial monitor. And when I open my serial monitor, I'm going to be at 9600 baud. So what I'm going to do is make sure that I change that 9600 baud to 1200. And when I do that and I test my read, lo and behold, I have a sensor that goes from 0 to 1023. Okay, looking good. I like that. Make sure to close out your serial window, your terminal window, because if you don't, then processing can't open that port. The next thing I'm going to do is scroll down and grab all of the code above where it says max MSP v5 patch for this example. There's a second chunk of code in here for max MSP. It's a little bit beyond what we're going to do today, but know that it's there and you can use it. So this code is all commented out. So what I want to be careful to do when I download this is not take the comments, or when I get it into processing, remove the comments. So I'm going to Control-C copy this processing code for this example, and then I'm going to go to processing. So I'm going to dump my Arduino sketch down. I'm going to open up processing. And Java is a little top heavy for the Raspberry Pi, so things slow down most immediately. Megan, we got any questions? Fan mail?
We're good.
Requests? Should I do this as a musical number?
Absolutely.
Yeah. I'm a great dancer. So we got the spinning hourglass here as processing opens up. We're asking a lot of this little Raspberry Pi. We're running Arduino, we're running processing, and we're doing VNC. So this is the little Pi that could right here. So here's my processing sketch. I'm going to close out the splash window, Control-V, paste that code in. Great, looking good. So I'm going to make this big. I need to make some changes to this code in order to get it to run. So what I'm going to do is I'm going to scroll up to the top, and in this, there's a port declaration on line 27. It says my port. And right here, what it does is it actually lists the serial ports when I run this example. So the first thing I'm going to do is break this. I'm going to run it. And it takes a little while for it to fire up. And you can see I got a bunch of errors in the console down here. But more important than the errors is the first thing I see, which is the serial list, which is part of my port. So I'm going to close this sketch out. I'm going to stop it. And you can see I've got a device on serial 0, a device on serial 1, a device on TTY AMA 0, a device on TTY S0, and a device on TTY USB 0. And that should look relatively familiar because it's the Arduino that we just programmed through the Arduino program. So I know that that port is where this processing sketch needs to look to get the data coming from the Arduino. So that, if I count my devs and we start counting with 0, is 0, 1, 2, 3, 4. So the port that I'm looking for is port 4 in this list. So I'm going to go up here and I'm going to change this to port 4. I'm going to change that 9600 to match the baud rate that I built in the Arduino sketch. So I'm going to change that to 1200. In draw, I'm going to add a delay because I need everything to slow down a little bit. So I'm going to say delay 20. close that out with a semicolon. And I'm going to run this. And when I do, you can see that I get my nice purple window that starts to move with my potentiometer. So as I turn the potentiometer up, we go all the way to the height of the window. As I turn it down, we go all the way down. When we get to the edge, start all over again. And so we have an analog conversion running on an Arduino right into a data visualization and processing on the Pi. So this might be the easiest way into data visualization that I know of. It's usually the first data visualization program that I show anybody who's interested in this. And this can be adopted to a light sensor or any other analog sensor for that matter. So every once in a while, this will kick out an error. You can see in the console down below that I've got a not a number error. If you get enough not a number errors, basically it shuts the serial event down. But the reason that I slowed down the baud rate and I put the delays in was to kind of build in a little kind of redundancy so that the Pi in its slowness can actually build out the data form before it times out. So, and I had an interesting one there where it skipped the end of the data and wrote over itself. You can see there's some gaps in the data in this. And that's just inherent in the fact that we're not running like a full speed program on here, and we've got some computationally intensive stuff going on. And you can see it just quit. It says in my console, it says error disabling serial event for /dev tty USB. If it gets enough non-numbers, if it's reading the frames in the middle, it'll shut down and you got to restart. And there's a little tuning. I just kind of whipped this example up last night and this morning. So there's a little tuning that could probably go on with this, but it does work, and it's a good place to start with data viz with processing.
Second, and Brett.
Great. So those are the two examples that I built for today. I'm going to add a link with the example code and the website stuff to the YouTube page. I want to thank you for joining me this afternoon. Megan, do we have any questions? Great. Perfect. Thanks so much.